Alright class, in this video we learn about the inverse cosine function. And so in section 6.4 of your textbook, and so we're starting at the top of page 8 in your lecture handout. So just like the sine function, the domain of the cosine function has to be restricted in order to define an inverse cosine function. So back in section 5.3, you learned about the graph of the cosine function, right? Its domain is all real numbers, and the range of the cosine function, right, again goes from -1 to 1. And so you can see that the graph of the cosine function fails the horizontal line test. So as is, right, you can't define an inverse cosine function. But way back when, mathematicians wanted an inverse cosine function. And so how they got around this problem is they restricted the domain of the cosine function for values of x from x equals 0 to x equals pi. So they kept x equals 0, x equals pi, and you notice that they just kept this part of the graph right here. So in this part of the graph, the range is still from -1 to 1. So that's what we have down here, right? The graph of the cosine function from x equals 0 to x equals pi, which is the same as 0 degrees to 180 degrees. And they threw away everything to the left of x equals 0 and threw away everything to the right of x equals pi and just kept this part. And you can see this part of the cosine function passes the horizontal line test, and so it has an inverse. And so this is the graph of the inverse cosine function down below. Remember, the -1 on the superscript of the cosine does not mean reciprocal. It's just fancy mathematical notation to indicate this is the inverse cosine of x. So x is the number you put into the inverse cosine function, and y is the angle that comes out. And so you can see the domain of the inverse cosine function goes from -1 to 1. Those are the numbers you can put in for x. And then the angles that come out y go from 0 to pi radians, or 0 degrees to 180 degrees. So this point right here says the inverse cosine of 1/2, right? 0.5 is the same as 1/2. The inverse cosine of 1/2 is equal to pi over 3 radians, which is the same as 60 degrees. So on the next page, we summarize the domain and range of the inverse cosine function. The numbers you can put in for x, right, again, are from -1 to 1. That's the same as with the inverse sine function. The angles that come out, y, okay, you put in a number in for x, and you get an angle for y that's between 0 and 180 degrees, or 0 and pi radians. And so the inverse cosine function uses the angles from 0 to 180 degrees on the unit circle. Right, here's 0 degrees, here's 90 degrees, and here's 180. So those are the angles that come out of the inverse cosine function, right? They're between 0 and 180 degrees, right, going in a counterclockwise direction. So if y is the output angle equal to the inverse cosine of the number x, then it has to be true that the cosine of that angle y is equal to the number x. So down below, right, I summarize the numbers, the angles that come out of the inverse cosine function for the numbers that you can put in for x. And so over here on the left, right, here we have the angles theta and the corresponding value of cosine theta. So we know 30 degrees and is the same as pi over 6 radians, and so the cosine of 30 degrees is equal to the cosine of pi over 6 radians, which is equal to the square root of 3 over 2. So consequently, the inverse cosine of square root of 3 over 2 is equal to the angle pi over 6 radians, which is the same as 30 degrees. So let's take a look at another one. We know that 135 degrees and 3 pi over 4 radians are the same angle. And so the cosine of 135 degrees and the cosine of 3 pi over 4 radians are both equal to minus square root of 2 over 2. And so the inverse cosine of minus square root of 2 over 2 is equal to the angle 3 pi over 4 radians, which is the same as 135 degrees. So let's look at some examples on the next page. You're asked to find the exact value of each expression. So first you're asked to find the inverse cosine of the number 0. Well, from the table on the previous page, the cosine of 90 degrees is equal to 0. And the cosine of pi over 2 radians is equal to 0. So consequently, the inverse cosine of the number 0 is equal to the angle 90 degrees, which is the same as pi over 2 radians. In the next example, you're asked to find the inverse cosine of the number minus 1. Well, from the table on the previous page, the cosine of 180 degrees is equal to negative 1. The cosine of pi radians is equal to negative 1. So consequently, the inverse cosine of the number negative 1 is equal to the angle 180 degrees, which is the same as pi radians. In the next example, you'll find the inverse cosine of minus 1/2. Well, from the table on the previous page, the cosine of 120 degrees is equal to minus 1/2, and the cosine of 2 pi over 3 radians is equal to minus 1/2. So consequently, the inverse cosine of minus 1/2 is equal to the angle 120 degrees, which is the same as 2 pi over 3 radians. And then lastly, you got to find the inverse cosine of minus square root of 3 over 2. Well, from the table on the previous page, we know the cosine of 150 degrees is equal to minus square root of 3 over 2. And the cosine of 5 pi over 6 radians is equal to minus square root of 3 over 2. So consequently, the inverse cosine of minus square root of 3 over 2 is equal to 150 degrees, which is the same as 5 pi over 6 radians.